Okay, properties of real numbers. First property of real numbers that we're going to address is called the commutative property of addition. What that means is that it doesn't matter what order you put letters or numbers whenever you add them, you're going to get the same answer. So you can add A plus B and you'll get the same answer as if you add B plus A. Now here's an example with numbers. We've got 10 plus 12. If we add 10 to 12, what do we get? 22. And then we come over here. We've got 12 plus 10, just the opposite way. 12 plus 10 is 22. So you get the same answer. It doesn't matter what order you do it in. The same thing applies to multiplication. The commutative property of multiplication says that you can multiply things in any order that you want to. You can multiply A times B or B times A and you're still going to get the same answer. For example, 2 times 5 is 10. 5 times 2 is 10. Same answer. See, so it doesn't matter in addition or multiplication in what order you do the addition or multiplication. But let's look at this. What is 5 minus 4? Okay, is that the same as 4 minus 5? Well, 5 minus 4 is 1. Okay, we know that. And 4 minus 5. Now we've got different signs, so when we have different signs we get the difference between the two numbers. 5 minus 4 is 1. And we keep the sign of the bigger number. The bigger number has a negative sign. So we did not get the same answer. So there is no commutative property of subtraction, just of addition. And the same thing for division. 6 divided by 2, is that the same as 2 divided by 6? Well, 6 divided by 2 is 3. 2 divided by 6 is 1/3. See, so they're not the same either. So there is no commutative property of division, just of multiplication. Next thing we've got is the associative property of addition. What that means is it doesn't matter how you arrange the numbers or letters, it's going to come out with the same answer. So we can add A to the sum of B plus C, or we can add the sum of A plus B to C. Let's do that with numbers. We've got 5 plus 6 plus 11. So let's do the parentheses first. So we've got 5 plus 6 plus 11 is 17. Then we go 5 plus 17 and we get 22. Then we come over here and we've got it arranged a little bit different. We've got the 5 plus the 6 done first. So 5 plus 6 is 11 plus 11, and 11 plus 11 is 22. See, so it didn't matter what order how we associated the numbers together, we got the same answer. Alright, the associative property of multiplication. Same concept here. Doesn't matter what order you multiply the numbers in, you're going to get the same answer. Look at this. 2 times 4 times 6. 4 times 6 is 24 times 2. 2 times 24 is 48. Over here we've got 2 times 4 is 8 times 6, and that gives us 48, which is the same thing. See, so you can do the multiplication in any order that you want to, you're going to get the same answer. Okay, the identity property of addition. Anytime that you add 0 to a number, you're going to get the same number. So if I add 0 to A, I'm going to get A. If I add 0 to 8, I'm going to get 8. If I add 0 to Bob, I'm going to get Bob. Okay? It doesn't matter. As long as you add 0 to something, you're going to get that same item. Okay? So that's the identity property of addition. The identity property of multiplication. Any number that you multiply by 1, you're going to get the same number. Okay? A times 1 is A. 8 times 1 is 8. Once again, Bob times 1 is equal to Bob. What it means is it retains the same identity. Up here we have A, we add 0 to it, it's still A. Down here we have A and we multiply it by 1 and we still have A. So that's the identity property of addition and multiplication. The zero property of multiplication is whenever you multiply a number by 0, you're going to get 0. It doesn't matter what you multiply by 0, you're always going to get 0. A times 0 is 0, 9 times 0 is 0, 1/3 times 0 is 0, x squared y to the 3rd, z to the 14th divided by 853 times 0. Yes, it's going to be 0. It doesn't matter. It doesn't matter. As long as you multiply it by 0, you're going to get 0. Alright, the next one is the multiplication property of -1. All that means is that whenever you multiply it by -1, you're going to change the sign of the answer, okay? So if we started out with a positive A and we multiply by -1, then we get negative A as your answer. If we start out with 7 and we multiply it by -1, then it changes it to a -7. What about this? What if I start out with -7 and multiply it by -1? Yes, it changes the sign in the answer. So instead of a -7, it would be a +7. So when you multiply by -1, it changes the sign of the answer, okay? Use the properties of real numbers to simplify the following. 5 times 3n. Well, what you're supposed to see here is that it doesn't matter what order you multiply the numbers in, okay, or letters. So since the 5 and the 3 are alike, they're both numbers, not a letter, we group them together and then we multiply by n. So that would be 5 times 3 is 15 n. Okay? Now down here we want to add like things together. The 4 and the 7b you can't add together because they're not alike, okay? But you can add the 4 and the 8. So what we'll do is we'll go 4 plus 8 plus 7b. And that gives us 12 plus 7b. Okay? And then over here we've got 6xy over y. Well, that could be 6x, okay, times y over y, like that, okay? What do you know about y over y? Any number over itself is equal to 1, okay? And 6x times 1 is equal to 6x.